We've been studying surface area, which means that basically you want to think about, okay, what would be the surfaces that we're going to cover or paint? How much paper would it take to wrap it up as a present? Volume, on the other hand, is filling it up. So we want it's going to take up space. It's going to be a solid. And so what we want to know is how many liters of water, how many cubic centimeters, how many whatever, we want to fill it up. So the way that you do that, so we're doing cylinders and prisms today. And the reason we're doing those is because their equation is the same. To find the volume of a prism or to find the volume of a cylinder, it is the area of the base whatever the base may be, and then h is the distance between the bases. We don't want to say height because it's not necessarily standing up. It may not be standing on its base, and so we want to differentiate and say that it's the distance between the bases. When it's a rectangular prism like we have in number 1, you can use whatever base you want. We tend to use the one that it's sitting on, where we want it to be. And so we have our base and we have our height. Those are the two pieces that you need. So it's the area of the base. The base is a rectangle. And so the area of your base would be 3 times 8, which is 24. And then your height would be 5. And so your volume will be then 24 times 5, which is 120 meters cubed. Now in number 2, we have our base. Remember, to find your base, basically on a prism, if it's anything other than a rectangle, then that is going to be your base. So my base is my triangle. What we look for is the ones that are congruent and parallel, meaning they don't cross and they're the same size. So that, in this case, is the area of a triangle. So I need to find the area of that triangle. This is a right triangle, and we're really struggling with this. We already have the base and the height. We don't need to draw it in. Y'all are so accustomed to doing that when you have an isosceles triangle or something else. You don't have to do that with right triangles because we already know our base and our height. Well, the area of a triangle is base times height divided by 2. So the base of the triangle is 3. The height of the triangle is 1, and that's divided by 2. So the area of the base is 1.5. And so then the volume of the shape is the area of the base times the height of the shape, right? Now imagine yourself turning that triangular prism up on the triangle, then it would stand 2 feet tall. So we would say times 2, so that would give us 3 cubic feet, or feet cubed. Okay, so number 3, again, when you have a prism, always look for something that is not a rectangle, because in this one we do have rectangles that are parallel to each other, but they're not congruent. And so the base is the trapezoid. I've got all these measurements down here already. So I'm going to take a break for a second. I need the area of the base. I need the area of the trapezoid. Well, that's 1/2 base 1 plus base 2 times the height. Okay, only look at the yellow trapezoid. That's it. Now, part of the problem here is we don't know the height of the trapezoid that we need. The height is that vertical height, and we need that. But what I do know is this. Let's look at the rest of the information we have. I know that this is 7, which leaves me with 8 to go to those triangles. And since this is an isosceles trapezoid, that means that this is 4 and this is 4. Well, since the hypotenuse is 5 and this side is 4, that means that the height of the trapezoid is 3. So we have 1/2. Base 1 is 15. Base 2 is 7 times 3 divided by 2. And we find out that the area of our base is 33. So then the volume is the area of the base times the height. The height is the distance between the two bases. So you want to look for that, find a spot on the trapezoid and then drop it straight down to the other one. And so the height is 20. Oh, not 30, 33. That was 33 also. 33 times 20. And so you get that the volume of this trapezoidal prism is 660 meters cubed. Okay, number 4 is a triangular prism. Again, we've got our base, so we look for our base. In this case, I don't have a right triangle. I have an equilateral triangle. So I am going to need to find out some information. So volume is the area of the base times the height. So I'm going to go over here. I'm going to find the area of the base. Well, that's 1/2 base times height. So just look at the triangle. We need a height. We don't have one. Well, that dropped that in down and split that bottom piece in half, that base in half. So that's 5. Well, if you notice, and if you had thought about it, an equilateral triangle is equiangular. This is a 30, 60, 90 triangle. If you don't recognize that, then use Pythagorean theorem using the 10 and the 5, and you can do that you can get the same, you'll get it in decimal form, but I'm just going to shortcut it and go straight to 5√3 without having to do the Pythagorean theorem math. I'll get the same answer in the end. So the area then of the base would be 1/2 the base, which was 10, times the height, which was 5√3. Okay, so I'm just going to keep it. I'm not going to do anything with that √3 until the end. So that would be 25√3. Half of 10 is 5. 5 times 5 is 25. Then I'm going to come over here. So the area of the base is 25 times the square root of 3 times the height. This is where you have to be careful. The height is the distance between the bases. So imagine standing this up on its end and multiply by that 13. Okay, so that's the height. That's how tall it would stand. That's the distance between the bases. So you have 25√3 times 13. That's 325√3 or 562.9 if we were to round, and that would be in meters cubed. Volume is in cube. Meters times meters times meters. Okay. So number 5, same formula, nothing has changed. It's a cylinder, but it's still the area of the base. So volume is still the area of the base times the height, but the thing that we like about cylinders is just like we liked it before, is that the base is always the same. So in this case, the base is a circle. The area of the circle is pi r squared, so I can take care of this all at once. Pi r squared, and then times the height. The height is, again, the distance between the circles. So times 6. So when we can, we like to leave these exact. So 25 times 6 is 150 pi. Or if I ask you to round it to the nearest, you would say 471.2. And that would be meters cubed if I ask you to round it to the nearest tenth. So 6 is the volume of the right cylinder is 1,253 cubic centimeters. Find the radius. So remember that you want to set it up. So volume is pi r squared h because the base is a circle. And so we're going to go with our circle. So then substitute in the numbers that you know. 1,253 is equal to pi r squared. That's our x because that's what we're looking for. And then our height is 10. So you need to do all the math that you can do. If it helps, then you can rewrite this 1,253 equals 10 pi x squared. So because we can, let's go ahead and just keep this. Be careful if you're using a regular calculator. If it doesn't make it into a fraction, be careful that you divide by 10 pi in parentheses. And so you get x squared is equal to 39.88. Carry your decimals out as much as you can, and then when you do that, you'll take the square root because that's what x squared is, but I want to know what x is. So I have to take the square root of both sides, and I get that x is 6.3. And so the radius of my cylinder would be 6.3 centimeters. Now, we have been talking about these 5 and 6. These are called right cylinders, and we used all right prisms up here. That means that the base, the big B and the base, are at right angles. Okay, so like this right here, that height is at a right angle to the radius. Okay, same thing here, or they are at right angles to each other. That's called a right cylinder. Okay, these are called oblique cylinders. So oblique just means that they're leaning over. Now, you're still going to use the same pieces. You still need H, but at this time, it's H how tall it is, like how tall it's standing up off the ground. And so that's where you have to be careful. So what you're looking for is you're still looking for that little H, right? That little H, it's backwards, but we're looking for that little H right there for our height. And so we still use the area we still use the area of the base times the height. The area of the base, the shape of the base is a circle, so that would be pi r squared times the height. Now, your vertical height, how tall does it stand up off the ground, is 8 inches. So it would be times 8. So you have 25 times 8, that's 200 pi inches squared. Or if you round it to the nearest, and it says to leave your answer in exact form, so we're going to leave it like that, 200 pi inches squared. You could have multiplied that by pi and gotten your decimals. Okay, number 8. So number 8, notice this time. So 18 is your diagonal. Okay, and so that's not how tall it stands. That's not its height to get through the door. But we need the height to get through the door. We need its vertical height or its distance between the bases. See, 18 is not the actual vertical distance between the bases. And so that's what we need. We need where this little h is. Again, it's backwards, but so we need to figure that out. Well, if I take this over, that's 18. This, notice, this is a 60-degree angle. That's there for a reason. Again, we've got our 30, 60, 90 stuff going on. This is my 2x side. That means this is my 30-degree angle with my 60 there in the bottom left-hand corner. So this is my x. This is my x root 3. I don't care about x. I don't need it. What I need is the height. So this is what I need. So that means that x is 9. So the height then would be 9 square root of 3. Now it says round to the nearest hundredth. So we need the area of the base times the height. So we need pi. Okay, the diameter is 12. So the radius is 6. So pi r squared. And then times the height, 9 root 3. So you can type that straight in on your calculator. It's ugly if you leave it exact, 324 pi root 3. I always put my square roots at the end so that I don't mistakenly put something underneath the square root that's not supposed to be there. But it says to round to the nearest hundredth, so you would type all of that in, pi times 6 squared times 9 times the square root of 3, and you get 1,763.01, and that would be millimeters cubed. So on number 9, the volume, the cylinder has a volume. So I have given you the volume. That's V. If the radius is the same length as the height, find the radius of the cylinder. I think this is a good time to draw a picture. So it says the radius is the same as the height. So I'm going to label my radius and my height the same. So find, and since I'm doing it in terms of radius because I'm asking for the radius. Instead of calling everything H, I'm going to call it all R. Which in the end, it doesn't matter as long as you recognize that height and radius are the same. So the volume is the area of the base times the height. So volume is the shape of the base is a circle times the height. Well, the volume was 512 pi equals pi is pi, r squared, and then h is the same as r, so I'm going to replace h with r. Well, then this right here, r squared times r is r cubed. So 512 pi is equal to pi times r cubed. Now I need to get the r by itself, so I'm going to divide by pi. So that's nice because it just cancels out. So this pi cancels that pi. It leaves me with 512 is equal to r cubed. Now on your calculator, you have a key under the math menu. If you go to math, there should be, I think it's like number 3, you should have something that looks like that, cube root. And you want to take the cube root instead of the square root. You want to take the cube root, because this is r cubed, so you want to take the cube root of 512. Or if you don't remember how to do that, then you need to start guessing. 2 cubed, 3 cubed, 4 cubed, 5 cubed. Well, you'll get to 8. 8 cubed, so the radius is 8. 8 times 8 times 8 is 512. So the volume of a cylinder and a prism is the same. They both have 2 bases, and so we're going to use volume is equal to the area of the base times the height. The only thing that changes is the base because the shape changes, and you use whatever shape it is on the front of your formula chart to find out what the area of that is, and then h is the distance between the bases.